All right, I'm going to start talking about Project 1. I don't particularly expect you to start working on it immediately, but I bring it up now because I want you to start thinking about it. Fair warning disclaimer, so far every student has consistently told me that this is the hardest project. Not because it's code-wise it's the hardest one to do, that's going to be your last project, but the problem is by this point in how much of a, I guess, how far along you've come in programming ability, this size of project is going to be very daunting. So yes, if you have a hard time with this project, I get it. Write something that works, get some points, and a lot of students they'll get their 60 on this project or 30. They'll go through the rest of the course, and all of a sudden, you know, they have their coming to Jesus moment, but with data structures, right? Coming to data structures, whatever you want to call it. And then they come back to this and go, oh, and then they're done. So this is going to be, I know it's going to be really hard, but this is how we got to go about it. We got to delve right into it and figure it out. So Project 1, large map. By the way, you're going to start looking at this. If you think you should use a hash map, don't. Do not use a hash table, all right? Do not use it. You will get a 0. All right. Storing and searching based on key value pairs is a very common problem in computer science. Complex data structures exist for general purpose searching and sorting, but if given some interesting constraints, you can actually come up with a very highly efficient data structure for this, or you can come up with some general ones, which is perfectly fine, and will get you some passing or close to passing grade. Our map is going to map, a string to a value. For example, you may have welcome back. You may have a student's name and you want to map them to their student ID number. You know, like here at CSU, the student name, map it to an ID number. You got it, you add a bunch of names with IDs, and later you're going to ask, hey, what is Kyle Flynn's ID number, and they'll give it back to you. Okay. Names, a single array of characters. And it's actually going to be alpha characters, uppercase and lowercase, and a space. So there you go. First and last name separated by a single space. The first letter of each name shall be capitalized. The rest is in lowercase. In between each first and last name shall be a space. Every student's name shall map to a single 32-bit integers. All IDs will be strictly above 0. So all your integers are above 0, and every student is only going to have one ID, and every ID is, shall map to a single, no, so I'm not saying they're unique. Certain students may have the same ID. That's just how it's going to be. But every name will be unique. It's very imperative you think about how we can simplify this problem given constraints. Oh, I can't go to the board because my... Oh well, sorry online student, you don't get to see what I'm about ready to draw. So, let me jump down to the code. Here we go, void add. So we're going to first create a map. I'll call it M. We do m.add. Give me a name. Give me a name. Jack.
Jack
Sparrow. I thought you were going to say black for a second there. Give him a name.
That's Sparrow's
All right. How about another name? Batman. All right, let's put a space in between it, because it needs to have a space. Oh, I did that on accident. And what's next?
Jack Black.
Jack Black, sure. Maybe I'll see the Muppets with Jack Black in it. Oh, that one was hilarious. They had to restart the Muppet Show, and they needed to have a celebrity. So they went to Jack Black's trailer and just kidnapped him and dragged him in and threw him in. It was great. All right. Anyways, so this is the setup. This is what I'm going to do. I'm going to call your code adding a bunch of names. Obviously, it's going to be more than 3. You should expect the first one to be a couple of thousand, with others being in the hundreds of thousands, if not millions. Yeah. Now, the way we're going to test this, I'm going to create an ID value, and then I'm going to do m.get, and let's go ahead and get Jack Sparrow. Ooh. And then at ID. What's that at sign doing? It's generating a pointer to ID, right? So, what should this return? First off, if you look at the code, m.get should return a Boolean, return true. To set the value correctly, returns true. Otherwise, this function returns false. So, does Jack Sparrow currently exist inside the map? Yes. So this should equal true. And what's ID going to equal afterwards?
It's pointing to his ID number.
So this generates a pointer to here, right? So then the point is that m.get is going to set what that is pointing to the ID value. Since it's pointing to this integer, it's going to set the ID equal to 1, 2, 3, 4. Okay? This is how you can have, this is how in C and C++ you can have a function basically return more than one value. Because it's returning a Boolean if it's true or false, and then if it's true, then you know to test the ID to make sure it's the correct ID. Let me show you a different one. m.get, we'll do Superman. What should that be? Whoops, I forgot to pass in my ID.
False.
False. And since it is false, you're not going to test for an ID because it wasn't found. All right? Okay. We'll get to remove in one moment. Prefix I've noticed is one that students have a little trouble with. Can y'all see down here, or is it getting too low? Getting too low, got it. Well, you just have to say too low, guys.
I just got to interrupt for a second.
Sure.
But looking at Batman, it looks like Buttman. And I find that hilarious.
Is that better?
Yeah.
Good catch. Sorry, online students. You're not getting any of this. All right. M dot how many? So this is going to return how many names start with that. So how many names start with that? 2. M dot how many? By the way, online student, I said capital J, lowercase a, lowercase c. That of course is 2. And what's another one? We'll do B-A-T. How many is that? 1. And just to drive this home, how many just start with a capital J? All right, how are we doing so far? All right, I'm going to do m.remove. Let's remove, we'll go ahead and remove Jack Black. Too late, I made my decision. So is this gonna fail or pass or fail? If I try and remove Jack Black, it'll pass, so it needs to return true. So that has to be true. Notice each one of these things I will be testing. And m dot how many Now that is not an M. What's that going to return?
1.
1, because we removed Jack Black. All right? All right. You have the high level view of what this is doing? Great. All right, let's go back and look at it. This is using a class, which we talked about, but we haven't gone into too much. You'll be going to classes next lab. I just want you to start thinking about this. I don't expect you to start coding it yet. Add function goes in and adds a key value pair to the map. Let's see, returns if successful in art. It's not successful if we are out of memory or if the key already exists. So you are going to go and search, and if you find the key, then you return false because it's already there. So if I did an m.add Jack Sparrow after all of this, it should just flat out fail. Searches for the key. If found, it sets return to the correct value and returns true. Otherwise, this function returns false. So this is the get down here where I pass it the name. And it returns true if it is in there, Jack Sparrow is, and then sets the next parameter ID equal to Jack, in this case, Jack Sparrow's ID, which is 1, 2, 3, 4. Size returns the size memory consumed by this data structure. We're going to get more into that later because you need to learn about the size of. But when you're towards the end of, when you're about ready to turn this in, or you're getting close to it, you want to start working on this function. Because I want to make sure you understand how much memory it's taking up. Remove removes an ID. So over here we were able to remove Jack Black because that's true. By the way, just for clarity, let's do m.remove. Do Jack Black again. What's that going to be?
False.
False, because we already took him out. How many returns the number of names with a given prefix. So up there, how many with JAC, capital J of course was 2, capital B, lowercase a, lowercase t was 1. In this example you have John, Jonathan, Paul, Mark, Luke, and Joanna. Of course I'm not putting in last names. JO is 3 because you have John, Jonathan, and Joanna. Constructor to free it. Private is where you're going to store it. Okay. Y'all understand the interface? Because that's the first thing we all gotta get going. Oh good, we're gonna have just enough time for them to walk in. That's gonna be hilarious. The crux of this problem is determining your data, what your data structure will consist of. I have provided a common list of first names and last names, if you wish to see them. Hey, first names, here's a bunch of them. And last names, here's even more of them. If you were to create an array of all possible combinations, it would take over 4.5 gigabytes. A list of all pop IDs would be just under a gig for a total of 5.5 gigs of memory, which may not fit in your RAM. So you may want to take some consideration on how you want to store it. The main thing to keep in mind is that we're really storing the ID, the integers, and then we wish to return them. We wish to retrieve them later. All right? This is the biggest hint I can give you. At the end of the day, we're storing an integer. Most of y'all will need to store the name. You store it as a means to get to the ID. All right? So you got to think about it from there. It is vital you think about your data structure before you start coding. I highly suggest you start drawing boxes and arrows. I haven't been able to do too much of that because we haven't gotten to that point yet. But please draw boxes and arrows. And if you have an ID, please come talk to me before you start coding it. You have my office hours. Hey. Yeah. And you can come in and ask for help whenever you wish. And here comes Valerie's sessions. Are we ready to do this? Oh, we got 5 minutes.
Good. How long is it? Nope. You want 5 minutes, Bill? Would you rather meet with these new people or spend 5 more minutes in here?
Should I answer that? Yes.
When you're searching for the names and stuff, is it all case sensitive?
Yes.
Okay.
It is case sensitive, but Hold on, let me answer this question first. It's technically case sensitive, but I am guaranteeing that all names are gonna fit the description of starting with a capital letter, and then the rest will be lowercase. So in actuality, if you want to assume that they're all lowercase, that's fine. Just make sure you convert them all to lowercase first. All right, that was a great question. Any
So-
others? Because we're gonna go over this again. I wanna just get this started now.
Oh, you're good, Ernest. Holland, you'll fill 111, right? Yes, perfect, Thomas, okay.
All right, great.
Anybody else cybersecurity as well as computer science? No? Okay, cool. Okay, they're next door.
All right,
I
so,
don't know what they're gonna ask, I have absolutely no clue.
so you want me to just send the entire class next door?
Yeah, pretty much. If you're
All
a
right.
computer science major, is anybody not a computer science? Like DS, computer science? Oh, yeah, like you wouldn't be in here, right?
Well, a BA would be in there. The BA has.
Anybody in a BA program? You don't have to go. But everybody else has to go, I'm gonna watch you. Amber's gonna count.
Yeah, I just got overruled by the chair, so there you go. All right, guys.
Thank you very
No
much.
problem.
I know it seems
They're all
bizarre.
prepped.
Very important.
Because I made sure I gave them 2 labs and a project today, so they would be ready.
Yeah.
Your brain hurts.
See, I'm used to that at this point.
Good.
So I'm not even surprised.
Good, excellent, thank you.
Oh, this is the time to see if my workload in this class is greater than my workload was in calculus. Oh boy.
Which calc? Calc 1 or 2?
Either.
Either?
Pick your poison, depending
It's,
on the manual we're at it.
Most said that the workload here was probably a little more than Calc 2, but Calc 2 hurt their brain more, I guess is the best way to put it. I
It
don't-
didn't hurt my brain, it just hurt my soul.
Hurt your soul. Now, a little pain's good for the soul.
Hey, Dr. West.
Yes.
Whenever I pull the upstream,
Yes.
it's not like I don't have lab 5 and stuff. I'm not sure if I set them right.
Sure. Do a get remote tech V.
Get remote. What?
Get remote
Oh, we're actually
space dash V. I sometimes say tac instead of dash. Hit enter. So your upstream is incorrect. You see how your upstream says Jacob Davies?
Instead of the CS.
Yeah, you got it. So you need to get remote remove. So let me
Okay.
let me
I
get
just tried adding it again with the correct one, and that didn't work.
All right, and you said you tried to add it? Is that up here somewhere? Add upstream.
It's probably.
There it is. It's right
Okay.
there. Oh, if you don't remove it first, it won't add it.
Okay.
So now we'll go up and do a get remote tech V. So that looks good. Go ahead and give it a try now.
All right. Awesome. Thank you.
Mm-hmm.